Hey guys, go ahead and take out your A.2.1 notes. Follow along as I teach it on this video. Feel free to pause it at any point if you want to try out the problem and see if you get the correct answer, or if you just need to catch up. So pause at your discretion. Otherwise, let's get started. Our three steps that you should always be thinking of when you are solving equations is first, are there any parentheses I have to take care of? We cannot solve anything if parentheses are not taken care of. So we first need to do that. Then we need to combine like terms. Let's look at the left side, look at the right side, and see how much we can get combined. And then that third thing, we want to get the variable onto one side and get the units on the other side. And when I say side, I mean the equal sign. So when we said left and right, we want to get all the variables on either the left or the right, and the units on the opposite side of that. So as we take a look at number one, I always like to split up my equal sign so we have the left side of the mat, the right side of the mat. There are no parentheses to take care of, so I'm going to skip to step 2 and say, do we have any like terms to combine? Remember, some of you want to combine these still and be like, oh, let me put those together, but when they're on opposite sides of the equal sign, you cannot combine them. Combining means it is on the same side of the equal sign, and you can put like things together. So this left side just stays as is. There is nothing we can combine together. But on this right side, there are 2 units and 11 also positive units. So we have 13 positive units. Some of you are trying to take 2 away from both sides, and when they're on the same side, you just put them together. There's 2 here, 11 here, altogether there's 13 positives, but we still have 16 negative y's. So we've done step 1, because there wasn't any. Step 2, we just combine like terms. So step 3, we want to get the variable onto one side of the equal sign and get the units on the other. It really doesn't matter which side you gather everything on, as long as the like terms are together. So I'm going to get rid of the y on this right side. And remember, the way we get rid of things is we do its opposite. So if we have negative 16 y tiles, we are going to do 16 positive tiles, because now we just made that 0 pair. But remember, to make things equal, if we put it on one side, we have to put 16 positives onto the other. And so negative 20 plus the 16 makes that a negative 4y. The more organized you can be, the easier these problems are to solve. So I'm going to bring down what I didn't use here. Now we got our y's onto one side, so get variable on one side, and so we want to get the units onto the other side. So we want, the way we have it, we want to get this 15 moved over there. Well, the way we move the 15 is if we have 15 positives, we're going to put 15 negatives to zero it out. If we do that to one side, we have to do it to the other. And so on this right side of the mat, we are left with negative 2. And this the left side, we still have our negative 4y. Our final step says we have to divide up those y tiles amongst the unit tiles. So notice I'm going to divide by negative 4. This is a negative 4, not a regular 4. So when we divide, that's what gets us, negative 4 divided by 4 gets us 1 positive y. If we divide one side by negative 4, we have to do the other, and we actually get positive 0.5. So each one y value is equal to 0.5. Now if you just said y equals 0.5, that is also fine. But remember, we're trying to find what one of the variables is equal to make the 2 sides equal. Alright, go ahead and pause the video. I want you to try 2 and see how far you can get, and then check your answer, whatever you get. Alright, go through each step. If you got that each y tile equals negative 8, nice job. If you didn't, go ahead and check the steps as to why you might have not gotten negative 8. Now, remember, equations are really nice because if you're not sure if your answer is right, you can go ahead and plug it back in. So we can put wherever y is, we can put that negative 8. And if it equals the same thing on both sides, then we have the right y value. So in this case, we would have negative 24 plus 10.5 equals to 6.5 plus, I'm going to pause so I can use my calculator and you don't have to waste your time on the video with me. Okay, so both sides equaled negative 13.5. The fact that they equaled the same thing meant that our y value of negative 8 worked for both sides. Alright, moving along now, we have some that have parentheses. So let's take a look at what happens with the parentheses. Remember what parentheses are saying? Before we just had a negative sign, we said everything is the opposite. But what this is saying is if we change this to x, this is like 4 groups of 2a plus 3. So if we had 2a plus 3, what that is saying, there are 4 groups of it. So there's one group, there's another, and let's just pretend it is all shaded in because it's positive. So that's what that is saying, 4 groups of 2a plus 3. Well, what that actually means is that once you solve it out, there are 8 A tiles and 3, 6, 9, 12 unit tiles. Well, hopefully you've seen this before, but we actually just use the distributive property. We multiply each term by 4, and that's how we get the 8a plus 12. But this is the picture representation of how that works. So first you see parentheses, you have to take care of those before you can move on with the equation. So we've taken care of the parentheses on the left side. The right side we have 31, and here is where it gets a little tricky. Remember how I tell you all the time, the sign in front of something stays with the value. So while it looks like a minus 3, this is actually a negative 3 we are distributing. Everything in here is becoming 3 times as big, and it becomes its opposite. So A, there's like a 1 with the A, that becomes 3a, but because a was positive, now it's negative. This is a negative 1, it gets 3 times as big and it's opposite, so now it is a positive 3. And so now, this turns into 31 minus 3a plus 3. Step 1 was to take care of parentheses. Step 2 is to combine like terms. This left side, everything is combined. We cannot combine A tiles with unit tiles. But this right side, if we have 31 positives and then 3 more positives, we have 34 positives on this side, but now we still have those negative 3A tiles. Okay, we want to get A onto one side. So it doesn't matter if we move the 8 or the negative 3, but usually we like to move our negatives so that we can keep things as positive. So if we want to get those 3 negative A's off that side, we are going to do 3 positive A's, and that makes our 0 pair there. But if we put 3 positive A's on one side, we have to put it on the other. And so altogether we get 11 A's now on this side. Plus we just bring down what we didn't use. And so step 3, we're almost done with it. We want to get the variable onto one side, but we want to get the units onto the other side of the equal sign. So we gathered A here. Let's go ahead and move that 12 over there so that our A term can be by itself. If we have 12 positives, we are going to have 12 negatives. If we do that to one side, we will do it to the other. Bring down our 11A, and this equals 22. Now we want to divide our 11A tiles amongst the 22 that are there, and we get that 1A tile is equal to 2 units. Or again, this is the same as A equals 2, so either is fine. And if you weren't sure if your answer was right, go ahead and plug in your 2 back in. Okay, I want you to try 4 on your own, but be careful, especially as I'm looking at this negative 5 that's in there. So go ahead and try it. If you want to see the distribution before you solve, play, do the first step, pause, do the first step, and then play. Okay, that is what the distribution looks like. Go ahead and combine your like terms, get x onto one side, units onto the other, and see what one x tile is equal to. I'm sorry, that should be 3x plus 18. I just had 8 there, so if you're looking and you're like, how'd she get 8? That should be 18. Okay, go ahead and finish this problem. Okay, x should equal 14.5. If you got that, keep moving on. If you didn't, go ahead and pause the video, check the steps, step by step of why you might have gotten it wrong. And then once you're ready, you can move on to the last part of this. What happens if there are fractions in the equation? Well, we do the same thing. We say let's get anything that is a variable on one side, anything that isn't the variable onto the other. Well, we should do parentheses first, but there was none of that in this one. So no parentheses. We're going to move on to getting that 1/3 x by itself. We want to get rid of that -2, that -2, so we're going to put 2 positives, which means 2 positives here. Now we have 1/3 of x equals to 5. Well, there is this trick when you have fractions. You multiply by the reciprocal. So if you multiply by 3/1, that is the reciprocal. It is the flip of a fraction. If you multiply by 3/1, that means, remember when we multiply fractions, we multiply straight across. So that means 3 times 1 is 3 over 1 times 3 is 3x. Well, 3/3 is 1x. That's what we're trying to see, what one of the x equals. And so anytime you have a fraction, you are going to multiply by its flip, or multiply by the reciprocal. So whatever you do to one side, you do to the other. So 3/1, you're going to put over here as well. And any number you can make into a fraction. So now when we multiply, we get 3 times 5, which is 15, over 1 times 1. So 15 divided by 1 is just 15. 1 x-tile equals 15 units. Well, what happens now that we do have parentheses? We have to do those first, and we're actually distributing this 3/4 here. Well, that seems kind of tricky, but just like before, if we multiply fractions, let's just make everything into a fraction. Let's put this 5x over 1, and let's put this -16 over 1. So that when we multiply, this 3 is actually multiplying the top, and this 4 is multiplying the bottom. So what we get is 15x minus 48, and then the bottom will be 4 times 1 and 4 times 1, and it equals 2. Well, now you should ask yourself, can I simplify either of these? 15 over 4, sure, you could turn into a decimal, but I want you to actually keep it as a fraction for now. If you get decimals, leave it as a fraction. Then you can do 48 divided by 4 and get 12. That's a nice number. And now this looks like number 5. I want you to see if you can get x by itself. I want you to use the reciprocal method. Alright, go ahead and pause and give it a try. Okay, we get that x equals 68 over 15. Now some of you might really want to call this a decimal. Let's see. Some of you might really want to call this 4.5333 repeating forever. And decimals are okay, but fractions are exact, so I want to urge you not to use the decimal and to keep things in their fraction form. Okay, we have 2 last ones. I'm going to stop the video here and put a part 2 out just because I get cut off at 14 minutes here from this website I'm using. So, look for part 2 for the last 2 problems.